What are some emerging trends in the field of AI which an architect should keep an eye on?
Well, certainly graph neural networks, I would say. I think that often, like, especially in the computer vision field, we've cared a little bit more about point clouds just because they're with LiDARs and whatnot. That's, it's easy to collect data. Well, assuming you have a LiDAR, it's easier to collect 3D data of a scene using that. And I think with graph neural networks, it's been kind of more, they're up and coming, I should say. So we've had some very interesting projects over the last 2 years in the studio. And so some of them, one in particular in this last studio, they took a generative adversarial neural network that transformed input sentences into images. And so what this group did is they would create images for letters, like the letter S, or they would create images for grass. And then they would use, multi-view reprojection to get 3D models out of this. And they actually used this method to populate a city block. And I thought that was a very interesting and kind of inventive way of using jointly using language and vision in the design process. Another group that I worked particularly closely with, actually, we developed an optimization framework where it would take in an input mesh, and you could specify desired silhouettes for the mesh, and then also desired acoustic properties for the mesh, and our optimization framework would transform it, and you would get the output would be the interior of a concert hall, a novel concert hall. And so there's a lot of different kind of cool things that you can do. Pretty much sky's the limit, I think. A lot of groups also kind of stayed more in the kind of neural style transfer realm, which is sort of what, has been popularized by like Google, and would take, they would spend a lot of time kind of looking through different images and trying to find ones that created very interesting transfers, and then kind of doing some clever work again usually with reprojection techniques to get it into 3D. And so I think, there's a lot of opportunities for, a lot of different algorithms. There's a lot of things we haven't tried yet that I'm hoping I see in the next studio that we teach. So. And Sandra Manager through the Taubman School of Design. And then the other is more of what my PhD thesis research is on, which is about autonomous vehicle perception. So more specifically, though, related to the work in architecture, my personal interests are kind of exploring the design process and sort of using, the internal models that algorithms learn as a way to kind of augment and potentially improve the design process for architecture. Yeah, so one of my favorite projects that I've worked on with Matthias and Sandra, we've called Imaginary Plans. And we started out, we wanted to see if it was possible for a network to generate plans. And we specifically were focusing on more of the creative aspect of, can we have an algorithm generate a novel floor plan as opposed to something that was necessarily optimized or functional or could be constructed. And so we took a neural network called a generative adversarial neural network. And so that term sort of describes a family of algorithms now. So there's a lot of different modifications and kind of more special architectures within that family. But the basic idea is that you have two networks that are training each other adversarially. You have the generator, which takes in an input noise vector and renders what we call a fake image. And then you have a discriminator network that's trying to learn how to differentiate between this fake generated image and then a training set of real images. And so, each network kind of has a different goal, but they both want to trick each other. And so in doing so and training the network and these two networks in this way, the generator produces more and more realistic images, whereas the discriminator kind of learns more and more detailed pixel patterns to associate with real images. And so it's a really cool idea, and training paradigm, and it's probably one of the biggest ideas in deep learning, I would say, in recent history. And so we wanted to see if we could take sort of this type of network and create it, what we would, as humans would say, is a creative floor plan. And so, one of the biggest problems, though, is that this type of network learns pixel information. It learns to predict pixels, not necessarily symbolic information. When we as humans look at floor plans, we see kind of what is captured by the pixels. We see a room, not just, a bunch of values of 255. And so that was something that we weren't really sure how the network would handle it, because we didn't want to inject any constraints outside of sort of creating a very curated data set. And so for this project in particular, what I had gone through and done is collected a bunch of traditional floor plan images and then intermixed with those a ton of different non-floor plan images. So ones of kind of more fractal art, ones of city maps, different kind of nature maps, and a lot of different forms of art. And we wanted to try to see if the network was sort of able to incorporate some of the structural visual features from these non-floor plans into the traditional floor plans. And thankfully, that is what happened. And we were able to create kind of very alien looking floor plans. And so they're very visually striking. One of the problems that still remains, that we're actually submitting a paper to this year's Acadia as, proposing a solution to it, is how to kind of now, once we're able to demonstrate that we can create sort of stylistic mashups between floor plans and non-floor plans using this family of networks, how can we actually inject constraints of the real world? So constraints that, windows should exist, doors should always connect to rooms. And so that's kind of where the project is now. But yeah, it was, I think the biggest challenge, though, is that as we were writing this paper, we were really struggling, I think, with the resolution of the images produced. There's a huge kind of computational constraint of training these networks. And we, unfortunately, at the time, were not able to get images generated that were larger than 512 by 512, which for designers is sort of scandalous. Those are very small images. And furthermore, the method that we were using in particular, called progressive growing of GANs, takes a very, very long time to train. So it takes weeks to converge. And so we were kind of struggling with sort of how to get less blurry images by figuring out ways to accelerate the training time, but then also how do we just get higher resolution images? And I think that, that's also sort of one of the avenues of future research. So I would actually say that some of the reasons why our methods have been successful is because we've created highly biased data sets. And so, kind of anticipating that, knowing that neural networks can, severely overfit, we actually kind of wanted to take advantage of that. And so with respect to this imaginary plans paper, the way that GANs work is that they sort of learn the space between images. So they're able to learn what the kind of shared features are between the images, and then are able to kind of, once you learn that, you're able to interpolate between images. And so we sort of took a gamble and said, if we have a floor plan image and a non-floor plan image, what if, again, we're able to sample in between that space? So we're able to sample feature, a floor plan that has, the traditional kind of wall, visual features that you would expect, like walls, but also maybe, interesting like cellular structure that would, rooms would kind of look like cells or whatnot. And so that was just sort of a guess that we had, and sort of it did guide kind of that intuition about how GANs learn guided how the data set was collected, because we ended up choosing non-floor plan features that had a lot more geometric structure to them, I think, than, normal, like if I were to just randomly, choose any art image. And so we did kind of benefit from, the fact that neural networks can be, data sets can be very biased. And that's kind of an interesting way to sort of, in the design world, are, because like in autonomous vehicle research, it's a huge problem to have biased data sets like that. But I think in design, it actually can be quite useful because we can, create sort of these, we can take advantage of that and have it, because our end goal is something that's very visually pleasing, and hopefully that can be constructed. And so I think it's something that, can definitely work in our favor. And so I think, once computer science skills kind of become more prominent in curriculum throughout architecture departments, I think that that will really help a lot. It will kind of be a lot more empowering, I think, for students, especially to incorporate, kind of, and once you gain these skills, it becomes a lot easier to kind of look at and see how to kind of incorporate artificial intelligence into your own design process, to the extent that